The problem that we are going to discuss today is from the recent June Cook-Off, and the problem name is too much XOR. Difficulty level of this problem is easy medium, and its prerequisites are the XOR operation and casework. Now let us proceed to the problem statement. Starting off with the problem statement, let's see what it is. Chef calls a sequence of integers a1, a2 up to an good if it satisfies the following conditions. So condition 1 is that ai XOR ai plus 1 is greater than 0. So basically the XOR of consecutive elements should be greater than 0, and ai minus 1 XOR ai XOR ai plus 1 is equal to ai for all valid I. So let us see what this statement means. Now ai minus 1 XOR ai XOR ai plus 1 should be equal to ai. Now if you check, these three are consecutive elements, right? That means if their XOR is equal to the middle element, that means the XOR of the other two elements should be 0, right? That means the other two elements should be equal. So here basically what they mean is a of I minus 1 is equal to a of I plus 1. And also these two elements should not be equal to ai. Why? Because of the first condition, right? This condition that ai XOR ai plus 1 is greater than 0. So our sequence will be something like x, y, x, y. So this will be our sequence where x is not equal to y. So this is a good sequence, right? Now in particular, any sequence with length 1 is good, and any sequence with length 2 which satisfies the first condition is good. Okay, now chef gives you a sequence a1 up to an. Now we may perform up to 3n operations over here as given over here. So the operation is given as we choose 3 pairwise distinct valid indices a, b and c, and we change ac to a XOR of the first element and second element. Now this means that the operation can only be performed for n greater than or equal to 3. So it is obvious that since we have to select 3 distinct indices, we can only perform this operation for n greater than or equal to 3. Now chef is asking us to make the sequence good using at most 3 into n operations, or report that it is impossible. Note that we do not have to minimize the number of operations. Okay, now let us see a quick example of where we can use this operation. So let us see, we have the array given to us 1, 0, 3. So this is our array. What we can do over here, we select the first two elements and we replace the third element with their XOR. So what is the XOR of 1 and 0? It is equal to 1. So the new array will be 1, 0, 1. If you check, this is of the form xy, xy, right? Alternate elements same and not equal consecutive elements. So this satisfies our condition of a good array. Therefore, this array is good. Therefore, our answer for this test case, it will be 1, 2, 3. Since we are selecting the 3 indices 1, 2, 3, and we are replacing the third indice with the XOR of the first two. So this will be our answer. Now we will see another sample case. So over here we have something like 1, 0, 0. So if you check over here, I can still perform the same operation, that I can replace the third element and again I will convert it to 1, 0, 1. Now but think, if this one was also 0, so we had 0, 0, 0. Since we have all zeros, no matter how many times you XOR it, you can never change it to a XY, XY type array, right? So in this case, the answer will be -1. So now we have seen a couple of sample cases. Now let us directly jump to the solution approach. Now let us start the solution approach. So first we will go case by case over here. So for the first case, we have n is equal to 1. So for n is equal to 1, we know the answer, it is always the array is good. So the answer for this case is that 0 operations will be required. Now let's go to the second case where n is equal to 2. Now for this case, there is one important thing, that if the two numbers, we will have two numbers which are a of 0 and a of 1. So if the two numbers are equal, then the first condition, that is ai XOR ai plus 1, this should be greater than 0. So this condition will be violated, right, if they are equal. So if they are equal, then the answer will be minus 1. Else the answer will again be 0, because 0 operations are required. Now we come to the main part where n is equal to 3. So for n is equal to 3, let us now consider the first case where the middle element. So let us consider it like this: A, B, C. So these are the three elements. So let us consider the first case where B is equal to 0. Now if B is equal to 0, let us consider that A is the case where A is non-zero. So A not equal to 0. So in this case, what we can do is we can directly replace. So what we can do is C, we can replace it, or rather A XOR B can be equal to C. So we can replace C by the XOR of A and B. And since B is equal to 0, the XOR of A and B will be equal to A, right? So the array or the sequence will become something like this: A 0 A. So this is again a good sequence. So in this case, one operation will be required. Now let us go to another version of the same case, that B is equal to 0, but A is, we don't know anything about A, but we definitely know that C is non-zero. So again, what we can do is we can replace A by the XOR of B and C. So B XOR C will be equal to A. And since B is 0, therefore the XOR of B and C will be equal to C. Now the sequence will become like C, 0, C. So this is again a good sequence. So in both of these conditions, there will just be one operation required. So here that operation will be 1, 2, 3. And here that operation will be 3, 2 and 1, right? Now let us consider the further cases. We have, as we so we still are in the case for n is equal to 3. So we have these three elements. So first we checked out where B was equal to 0, that is the middle element was 0. Now let us consider that B is non-zero. Now here let us consider one thing, that A is not equal to C. Okay. Now if A is not equal to C, let us check out. A is not equal to C. So we will just write some case. So 0, 1, 2. So this is a valid example of this case. Now if you see, no matter what you do in this case, the answer of this case will always be equal to minus 1, because you can't do anything to make this sequence good. Another case that that will appear is that all three of these are 0. So 0, 0, 0. In this case also, the answer will always be equal to minus 1. So these are the impossible cases for n is equal to 3. Now for the last case for n is equal to 3, let us consider that A is equal to C. So in this case, what we can simply do is we can just replace B by the XOR of A and C, and we already know that A is equal to C and these should be non-zero. Otherwise this case would already have been covered, right? So we should just replace the B by the XOR of A and C. That's it. So by this we cover all cases for n is equal to 3. Now let us proceed for n is equal to or n greater than equal to 4. Now for n greater than equal to 4, let us first eliminate the cases where the answer is either 0 or impossible. So the first case where the answer is -1 will be all zeros. So we already know that in case of all zeros, we cannot do anything. So the answer will be impossible, like -1. Now, let us consider this case that we have something like this. Sorry. So 0, 1, 0, 1, 0, 1. So in this case, the answer will be 0. Okay, because you don't have to do anything over here because the array is already good. Now let us jump to the main or to the remaining cases. So for the remaining cases, let us see the idea behind it. Now, in the remaining cases, we come across another case which is something like this, that all elements are non-zero, but they are equal. So x, 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 x. So these are all elements and they are equal. So what do we have to do over here? That just select any two odd placed elements. Let us select the first and the third element, and let us replace all the even placed elements by the XOR of these. So the answer will be something like this, 1, 3, 2. So with this operation, we replace this element with 0, then 1, 3, 4. With this operation, we replace the fourth element with 0. And if you check, if we do it for all even placed integers, then our final array will look like x0, x0, x, and so on. So this will definitely give us a good array. So this array is good. Now let us proceed to the general case where none of these edge cases appear. I know in this question there were a lot of edge cases and you may have missed some of them. Now let us consider the general case. So what do we have to do? First, we have to find a, a pair with the same parity. So with same parity, I mean the parity of index. So let us say we have an array A1, A2, A3, A4, and so on up to AN. Now, in this array, what do we do? First, we will check all the odd placed elements like A1, A3, A4. So, what we are trying to do over here, that we are trying to find a pair of elements which have XOR not equal to 0. So, for XOR not equal to 0, that means they have to be different elements. So what I do is I check A1 with all odd placed elements. So I will compare it with A3, I will compare it with A5 and so on. So if I get such a valid pair, then what I do is I simply replace all the even indexed elements with the XOR of A1 and whatever the second element was. But if I do not find such a pair, let us see what that case will be where I don't find such a pair. So if the array is something like this, 1, A2, 1, A3, 1, and so on. So basically here, all the odd placed elements have the same number. So I will not find a pair with XOR non-zero, right? So I will have to go into the case where I will now check the even placed elements. So now what I do is I compare A2 with A4, then I compare A2 with A6 and so on. Now it is definite that if I don't find an odd pair, so odd pair, if I don't find an odd pair, I will definitely find an even pair, because otherwise the case will be same as say 1 2 1 2. So this is already a good array, right? So this we have already covered. So this won't happen. So if I don't find an odd pair, I will definitely find an even pair. So let's look at the idea we are trying to do over here. So if I get an odd pair, say I get an odd pair of 1 and let's say any index C. So what I do is I replace all the even indices. So what I will do is I will write the operation as 1C2. So let the XOR of 1 comma C be something like B. So B is the XOR of 1 comma C. Now if you see, I have replaced all the even indices by XOR of 1 comma C, which is B. So the array will now look something like this: A1, B, A3, B, and so on. Now what I can do is, after I've completed these operations, so these operations will be 1C2, the next operation will be 1C4 and so on. Now, after I've completed the first set of operations, what I will do is, for the second set, I will just take any two even placed elements and I will replace the odd placed index by their XOR. So now the array will look like 0, B, 0, B, and we know that this is definitely a good array. And how do we know that B is not equal to 0? Because that was our condition of selecting the elements, that these should not be equal. Therefore, B will always be non-zero, right? Now, we come back to the case where we did not find a odd pair. So, we did not find a odd pair. Now, it is no big deal over here. If we did not find a odd pair, what we'll do is that we will just select the even pair that we found, and we will replace the odd placed indices with their XOR. So let us imagine the even pair was something like this: 2 XOR say D, and their XOR was equal to E. So what we did was we just replaced the odd indices by E. So it became E, A2, E, A4 and so on. Now again we applied the logic that we took odd placed indices, so 1 comma 3, and we replaced even. So this was the first operation, so this became 0. Then we replaced fourth, so 1 comma 3 comma 4. So this was the second operation, so this became 0 and so on. We made all even placed indices 0. So again, if you see, this sequence will become E0, E0 and so on, and this is again a good sequence. So I think we have covered all the cases. I know there were a lot of cases, but I think we have covered them all. So let us directly proceed to the C++ implementation, and please pay attention because it is quite a complicated and casework implementation. Let's go. So starting off with the C++ implementation, first let us take input n, which is the number of elements in the array. Next we take input the array and we store it in a vector. Now let us start doing the casework. So first, if n is equal to 1, we have the answer straight away as 0. Then if n is equal to 2, then we have again two cases. If the two elements are equal, or rather if they are not equal, then the answer will be 0 since their XOR is non-negative, or since their XOR is not 0, sorry. Else the answer will be impossible, because if the two are equal, then their XOR will be 0, and this violates our case. Now we come to n is equal to 3. So here I first declared a vector of tuple. So here I will store the operations that we do. I have again created a possible variable where I will check whether the operation, or whether it is possible to make the array good. So in the first case, we have the second element as 0 and the first element as non-zero. So over here we saw what we do. We replace the third element by the XOR of the first and second. Now here we have again the second element as 0 and the third element as non-zero. So what we do is we replace the we replace the first element as the XOR of the second and third. Now we come to this case where we are checking what conditions are impossible. So over here what we are doing is, if A0 not equal to A2, so basically the first and the third are not equal. So we saw that in this case, no matter what we do, we can never make the array good. And the second impossible condition was that all elements are 0. So in this condition as well, we cannot make the array good. So for here we see out -1 and we declare, or we give the value of the pos variable to false. So over to this condition where the second and third element are equal, we directly push back 1, 3, 2 over here. Now here we just check if it is possible, then we just output the number of operations that we used. So it is basically the size of this vector, and then what we do is just output the operations in order. So here, as I had stored a tuple in int, so here I can use this structured bindings, and I will just write x, y, z. Now we come to the case where n is greater than or equal to 4. So first we check all zeros, whether it is all zeros, because at all zeros case it is impossible. So here I use count a dot begin a dot end comma 0. If it is equal to n, that is we have the count of zeros as n, therefore our answer is -1. Next we check that if our sequence is already good or something like that. So I make two sets or of even and odd. In the first set, in the odd set, I insert all the odd placed elements, and in the even set, I insert all the even placed elements. Now I check if the size of the odd set and even set is 1. That means both of them, like they contain only one element, or like all elements at the even place are same, and odd elements at all elements at odd place are also same. Now we check if the element in even and odd set, there is only one element, right? So if it is the same, then so if it is not same, then we don't have to actually do any operations because the array is already good. So we will just see out 0. Else if they are same, right? So we have to do an operation that we saw, that I will either change all the even placed indices to 0 or all the odd placed indices to be to 0. So here I again make this operation tuple, and I push back 1 comma 3 comma I plus 1, where I is all the odd places. Now I again output my operations in this way using structured bindings. Now let us go to the last case where we actually check where two positions of same parity have different values. Now why we are checking this different values thing? Because we want their XOR to be non-zero. So first I will check even positions. So here I have fs1. So fs1 is my first element, and this is my second element. So initially I've initiated it to -1, and now I will check all the even positions. I will just compare, and if they are not equal, then I will set the value of sc1. Now, if I do not find any different even index elements, then the value of sc1 will remain -1, right? Then I will check like odd positioned elements or pair. So it is I proved it to you that if I don't find a even pair, then I will definitely find a odd pair. So here, using the same technique, I find a odd pair. Now, having found the odd pair, so I found it using the first element and sc2, right? So what I do is I now I now replace all even places by their XOR. So 1 XOR sc2, I replace all the even placed elements. And now what I do is, using the even placed elements, I replace all the odd placed elements by 0. So here these are the even placed elements. So this is one based indexing. So these are the even placed elements, and I replace all of them, all of the odd placed elements, by their XOR. So the array will become 0b 0b and like that. Now I again have all my operations in this vector, and I again output them. Else now we have an even pair that we found. So this was for the odd pair, and this was the even pair that we found. So if we found an even pair, then no need to go into this if condition. So here we just do the same thing, but for even pair, and we replace the odd indices by the XOR of 0 and sc1, and we again output all the operations on a new line every time. So this was the solution. This was a bit complicated, I know, but this was it. And let me share the link of the solution in a link below the video so that you can access it. I hope you understood it, and thank you.